This is the screencast for section 2.3, example 5. This is definitely going to be a review for you, finding zeros of a polynomial function, but better to review and make sure you've got this because you're going to need it. So a zero is also an x-intercept. It's where the graph crosses the x-axis. It's also called a root. Any point on the x-axis will have the y value 0. So to find the zeros of a polynomial function, we're going to set the output equal to 0, or the f of x value equal to 0. And then we are going to factor. So the greatest common factor between all three of these terms is x. So I'm going to leave that outside the parentheses. Inside I get x squared minus x minus 6. Now I could use quadratic formula from here. A would be 1, B would be -1, and C would be -6. But I do know that +2 and -3 multiply to be -6 and add to be -1. So I can make these, I can factor this trinomial into two binomials, x minus 3 times x plus 2. And then I can tell you that if x is 0, then this whole multiplication over here would be 0. If x is 3, 3 minus 3 is 0, and then everything over here would be 0. Or if x equals -2, then the whole thing on the right is also 0. Also the zero factor property that we discussed in chapter 1. So therefore, the zeros of the polynomial function are 0, 0, 3, 0, and -2, 0. Just to make sure, I graphed that on my calculator, and now I can hit trace and make sure that each one of those x values produces a 0 for the y value. I do have x equals 0 that produces y equals 0. Let's hit trace and see what happens when x equals -2. Also a 0. And then let's hit trace and see what happens when x equals 3. Also a 0 of the function. So my algebra was correct. The now try problem for example 5 is number 33. We're going to find the zeros of the function algebraically. Now, of course, this is practice, so I'm going to check it with my calculator at the end, but it does say algebraically, so I cannot find these zeros using my calculator. I need to use my good old-fashioned pencil and paper. All right, so zeros, again, land on the x-axis, so the output value is 0. So I'm going to change the output to 0. And I'm going to look into factoring this. Let's see. I could use quadratic formula. A would be 1, B would be +2, and then C would be -8. But I do know that +4 and -2, when you multiply them, you get -8, and when you add them, you get +2. So I can use those two values in my binomial, for my two binomials of what I'm factoring this trinomial into. So let's see, I'm going to use, what did I say, +4 and -2. So basically, if I FOILed that back out again and I multiplied, I would have a +4x term and a -2x term that would combine to be +2x, and then I would have a +4 and a -2 that would combine to be -8. So I have my two zeros. X equals -4 would make this whole right side equal to 0. And then x equals +2 would make the whole right side equal to 0. So my two zeros are -4, 0 and 2, 0. And now I'm going to check it on my calculator just to make sure. This probably wasn't a surprise to you, but the graph of this is a parabola face up. The same end behaviors, positive leading coefficient, so both of those end behaviors are going up to infinity. Let's see, I hit trace and I'm on the y-intercept. I want to know what the x-intercepts are. So I'm going to hit -4, and that does produce an output of 0, so that is one of my zeros. And then I'm also going to hit 2, enter, and that also produces a y value of 0, which makes a another 0.